In the last lessons, we learned how to write programs using variables, data types, conditionals, loops, arrays, and functions. But when we write code, it will not always work the first time. That is normal. Today, we're learning debugging, how to calmly find and fix mistakes in a program. A bug is not a failure, a bug is a clue. It tells us that what we thought the program would do and what the computer actually did are not matching yet. Debugging is the process of investigating that mismatch. The first debugging question is simple. What did I expect? And what actually happened? If I expected the answer to be 10, but the program gave me 9, I now have a clue. The goal is to find where the result became different. A good way to debug is to follow a cycle. First, predict what should happen. Second, run the code. Third, trace the code step by step. Fourth, fix one thing. Finally, test again. Do not guess randomly. Debugging is careful investigation. Beginner bugs usually fall into 3 groups. A syntax bug means the code is written incorrectly, so the computer cannot read it. A runtime bug means the code starts running but crashes later. A logic bug means the code runs but gives the wrong answer. Each kind of bug needs a slightly different kind of investigation. A syntax bug is like a grammar mistake in code. Here, the if statement is missing a colon. The computer does not understand the instruction properly. Once we add the colon, the code becomes readable. Syntax bugs are often fixed by checking spelling, punctuation, brackets, indentation, and symbols. A runtime bug happens when the program is running. In this example, the array has 2 items, apples and banana. Their positions are index 0 and index 1, but the code asks for index 2. That position does not exist, so the program crashes. A logic bug can be harder to notice because the program still runs. Here, the price is 100 and the discount is 20. If we want the final price, we should subtract the discount, but the code adds the discount instead. The program gives 120, but the expected result is 80. The code runs, but the thinking is wrong. One very common bug is called an off by 1 error. This happens when a loop runs one time too many or one time too few. Here, the array has 4 items, but the loop tries to visit 5 positions. The 5th position does not exist. This kind of bug happens when working with loops, arrays, and indexes. Tracing means watching values change one step at a time. We start with score equal to 0, then score becomes plus 5, so the value becomes 5. The score becomes score times 2, so the value becomes 10. If the value changes wrongly at any step, the bug is probably near that line. Sometimes we need to see what is happening inside the program. One simple way is to use checkpoints. We can print the value before an update, then print the value after the update. This helps us see exactly where the program changed the value. Simulations also have bugs. A cell may change when it should not. A pattern may grow too fast. A rule may behave differently from what we expected. When debugging simulations, we ask 3 things: the rule, the neighbors, and the update order. Small mistakes in these places can change the whole simulation. Large simulations are hard to debug because too many things are happening at once. So we start small. Instead of testing a large grid first, we test a tiny grid. A small test case is easier to understand. If the tiny version works, we can slowly scale up. Debugging is the process of finding, understanding, fixing, and testing mistakes in a program. It is not just deleting errors. It is learning why the program behaved differently from what we expected. Now it's your turn. Before running the code, predict what you think should happen, then trace the program step by step. Watch how each variable changes. If the result is wrong, fix one thing and test again. This is how we debug like programmers.